morning, grade 10th, and welcome to today's lesson. We are going to focus on relative density. If you remember well, in the previous lesson, I said in this lesson we're supposed to conduct an experiment on how we're supposed to find the density of a substance. But I've just figured it out. We are going to do it when you're in school, so that you'll be able to do it on your own, and not whereby you're just observing. So today I'm just going to focus on relative density. What is a relative density? Of which you understand. This is the definition of density. You know it. Now we're going to define relative density. So we're going to say relative density is the ratio of the density of a substance to the density of water. So this is just a ratio of the density of a substance to the density of water. So for short, what you're trying to say is relative density is equal to, you can say, let me just write it in words. So you're saying relative density is equal to, so density of a substance over density of water. Then you can say RD is equal to, then you know this is can say density. Now we understand you're not going to use the capital letter D like this, since we understand we're supposed to use the rho. So we're going to say rho, which is density over a substance over density over water. Now, since this is just a ratio of density of a substance to density of what? Water. And we cannot put units for this, or for relative what? Density. Because you understand this is what? A ratio. A ratio has got no units. So simply say relative density has no units because it is a ratio. Now, what you're trying to say is this: RD is equal to, so we are saying density over a substance over the density of what? Water. The density over water, like that. So if we were to put up the formula for the density of a substance, also the formula for the density of water, then let's try to see the formula that we're going to come up with. We substitute, we put the density for this, also the density for that. Then we see the formula that we are going to have. Because density, relative density, can also be presented in weight. So we start with the density of a substance. We know density is equal to mass over volume. Density is equal to mass over volume. Now let's take for the substance, you're going to say So for the substance, we say density of a substance. So I use S to signify or symbolize what? Substance. Is equal to, we're going to say mass of a substance over volume over a substance. Then for water, we are going to say, we know, I'll put W there, then which is equal to mass over water, then volume over water. So we know that for the substance, this is the formula, then for water, this is the formula. So we are going to substitute now in the formula for relative what? Density. What is a P substance, raw substance over raw water. Then we put now these formulas so that we see the formula that we can come up with. So I'll write it from this side. So RD is equal to, so we know that for the substance we are going to say is mass S over Vs. Then for water we are going to say mass W over Vw, like that. Then we know this is a division. So we are going to say Rd is equal to, then we'll simply say Ms, then Vs divided by this, which is a Mw over Vw, like that. Of which this can also be, if you change there, you're going to invent this fraction, of which you're going to say this is Ms Vs times. So they are going to have Vw over M, because you're inverting this like that. If you put a multiplication sign there, so water like that. Now, so if you multiply this, you're simply going to have a mass times a volume of water, mass of a substance times a volume of what? Water. Then down there you're going to have volume of a substance times a mass over water. Now let's assume that this, the mass, the volume of water is equal to the volume of a substance. We assume that the volume of water is equal to the volume of a substance. So you're going to say, okay, assume that Vs is equal to Vw. Meaning that they've got equal what? Since this is volume, the volume of a substance is equal to the volume of water. What does it mean? It means that if, take for instance, let's say if you have a 3 over 2 times 2 over, let's say 4. Meaning that these two, they are what? Equal. And if they are equal, they can simplify. Like that. So you simplify these two, there is 1, there is also 1. That's what it means there. If we say this one is equal to this one. So you're simply going to simplify this. You simplify these two.
Go.
Okay, so we're saying Rd is equal to mass of a substance over V over a substance times V over water, then mass over water. Now we said these two, if they are equal, then this one and this one, they'll go. So Rd is equal to mass of a substance over mass over water. So you're simply going to say mass of a substance over mass over water, like that. So this is mass, this is mass. So we're simply saying relative density can be expressed in mass. So mass of a substance over mass of what? Water. Instead of just using the raw or the density of a substance over the density of water, you can also use what? Mass. If you're given the masses, you're going to use what? The masses. If you're given density, you use what? Density. But again, I said relative density can be expressed in what? Weight. So what you're going to do there is, we know that mass can be gotten from weight. So the formula, so I'm putting up these things so that you'll be able to remember. We know that weight is equal to mg. Weight is equal to mg. Weight is equal to what? Mg. Like that. Are we together? Good. Now, if weight is equal to that, we are going to say we make m the subject of the formula. We are going to make m the subject of the formula, since you are saying mass can be gotten from this formula, of which we are going to say mg is equal to that. Then we divide by a g. We divide by a g. This is a gravitational force, which is 10. Then that one and that one goes. So we're going to say m is equal to this over, this is a weight over g. So that's the formula for what? Mass. Okay, so we have found the formula for mass. So mass, we are saying this is a W over G. Now, RD is equal to mass of a substance over mass over water. So we can substitute. On mass, we put what? This formula. Again, the mass of water also put this formula, of which we are simply saying this is equivalent to, so we say the mass of a substance, we use this formula. So we are going to say the new substance over G substance, of which we know is 10. The figure for gravitational force is what? 10. Then we're going to say W over, so this is a capital. Then there over G, this is water, this is a water, so this is a capital letter, then small letter there. Of which, if we assume to say this is 10, you know that this is a 10, this is also 10. It means these two are equal. So if we're to do the mathematics there, these two would just cancel. I'm sure if you have something like this, let's say 3 over 2 over 4 over 2. We are simply saying this fraction divide by this fraction. Instead of doing all those mathematics calculations, you just cancel, since the denominators they are the same. You just cancel these out. If you want to prove, you simply say this is a 3 over 2. Then obviously, when you change from division to multiplication, then you're going to invert this fraction. So it will be 2 over 4. There it will go, there it will go. Hence having 3 over 4, which is one and the same thing. So I'm trying to skip this stage over inverting the fraction which is on the bottom there. So hope you understand your calculations well. So simply cancel, since I know this is 10, this is also 10. I'll simply cancel a G and a G. Then what remains on top is the weight of a substance over the weight of water. So we'll simply say RD is equal to, we have a weight over substance over weight over water, like that. So this is also relative density. So density, I said one, it can be expressed in one using the density of a substance and the density of water. So the actual density of a substance in water. Then 2, you can also use a mass. Okay, you can use the mass of a substance. Let me use 2. Okay, 2, the mass of water. And the last one, you can also use the weight of a substance to water. So relative density can be found by using the actual density, which is a rho. Also the mass of a substance to water. Then you can also use weight of a substance to water. So this is how you're supposed to find relative density. So I'm sure for now, this is where I'm going to end. And in the next lesson, that's where we are going to do some calculations on relative density and the actual density. So I encourage you to stay home and stay safe.